Okay. Well, if you've done the atom inventory, you will now know that this is already balanced pretty much, right? We didn't need to put any numbers up there, correct? Okay. So I'm going to skip the atom inventory just for space here. All right? Okay, so what we want to start with then is either 5 grams of strontium chlorate or 4 grams of magnesium sulfate, and it does not matter which one you start with.
Shouldn't you start with the lower number?
No, it doesn't matter. Does not matter which one you start with. Is that the one you want to start with?
Let's start with magnesium sulfate. Magnesium sulfate. Magnesium sulfate.
All right. Listen, since it doesn't matter, let's take a vote. Everybody for strontium chlorate, raise your hand. 1, 2, 3. Come on, don't waffle. Raise your hand if you want strontium chlorate. All right, I'm seeing 1, 2, 3, 4, 5, 6, 7. Not 2 hands, please. All right, everybody for magnesium sulfate, raise your hand. 1, 2, 3, 4. All right, got magnesium sulfate has it. All right, we're gonna get the same answer. We'll get the same answer. I know. All right, we're going to start with 4 grams of magnesium sulfate. Okay, and we're always going to put that starting amount over 1, at least at this point in time in this class. That's where we start. Okay, and then we need to get from mass to mole, so we got to get to moleville. To get to moleville, we got to have a molar mass. Okay, so we need to add up the masses, the sum of all the atoms in the formula, right? Okay, so we need magnesium, and we need sulfur, and we need oxygen. And we go to our trusty periodic table and find that magnesium's atomic mass is 24.3050. And sulfur is 32.065. Yes, ma'am. You mean up here in the stoichiometry?
Yeah.
No, you're going to mark. You cancel out both units and species. Okay? And then oxygen is 15.9994. Okay? And then we need to multiply these by the number we have. And we have just 1 magnesium and 1 sulfur, but we have 4 oxygens. Okay? And we want to keep all of our numbers or digits here lined up nice and neat so we can do our rounding off when we need to.
Yeah.
At least that's the way I've taught you to do it.
Yeah.
Okay? Why don't I do 4 here? This is 3, isn't it?
Silly guy.
No, it is 4. That's sulfate. I'm sorry.
Yeah,
Never wrong.
I know.
See, even when you double check, you're still not wrong.
Okay. 15.9994 times 4. Okay, so 63.9976. Okay, and you can see then you've got 1 empty slot right here. That's why we want to keep all of our digits lined up nice and neat. And then we're going to add all these numbers together. So 63.9976 plus 24.3050 plus 32.065, and you get 120.3676. That last digit gets rounded off because it's insignificant, and we round off to
How would you feel if you were insignificant?
120.368 grams of magnesium sulfate equals 1 mole of magnesium sulfate. Okay? So now that we have an equality statement, we can use that to build the conversion unit up here. Okay? It's a little bit almost off the screen, but what we want to do is to put on the bottom of this conversion unit the part of the side of the equality statement down here that matches the units and species in the previous step. The previous step had units of grams and species of magnesium sulfate, so that's the side of the equality statement I want to put on the bottom up here. 120.368 grams magnesium sulfate 1 mole. Magnesium sulfate on the top, because that's the other side of the equality statement down here. It goes on the top. Okay? And we cancel as we go. So grams are going to cancel. I have 1 on the top, 1 on the bottom. The species magnesium sulfate cancels top and bottom. And we're now in Moleville.
Yay!
Okay, this is the outskirts of Moleville. But we need to get to the other side of Moleville. And to do that, we've got to go through downtown. And downtown is our mole ratio.
Turn your GPS on.
Okay? Alright, so
Moleville we go.
downtown Moleville is going to have a molar ratio. We need a mole ratio between magnesium sulfate and strontium chlorate. And 1 of each, right? 1 mole, because the coefficients here are 1 and 1. 1 mole of magnesium sulfate. 1 mole strontium chlorate. Okay, and we can cancel units, species. Okay, and now we're on the other side of Moleville. We're ready to go back to on the road here. All right, so we need to have a molar ratio. I mean, a molar mass for strontium chlorate. Got another, making them cookies. There you go. So strontium and chlorine and oxygen here.
Yeah.
All right. Our trusty periodic table tells us strontium has a mass, atomic mass of 87.62. Okay. Chlorine has atomic mass of 35.453. And oxygen is 15.9994. Yes, ma'am.
What would you use the answer you got for this was exactly the same as, like how much? So if we have less of the amount.
That's what you can't make the numbers lie.
Well, I mean, it's not greater, but it's not less.
Oh, if they're exact. Oh, okay, I see. So what you're at, here's, if I understand her question, here's her question. If the product mass over here is exactly the same as the amount that was given to you, right? So let's say we do all this math, and the mass we calculate over here is exactly 5 grams of strontium chloride. Then either one of those can be used as your limiting reactant. Okay? That doesn't happen very often. It could happen in your lab today. It's possible. If it does, I need you to, if it does happen in your lab, you have to explain it to me. You have to say on paper, I'm going to choose this one because. Okay? All right. Let's see, we haven't finished our molar mass calculation down here. So we've got 1 strontium up here. So times 1. Okay? We've got 2 chlorines. Got 2 chlorates and 1 chlorine on each chlorate. So 2 chlorines. So that's times 2. And we have 6 oxygens. Times 6. Okay? So we can put our 87.62 over here. And then 35.453 times 2. 70.906. 15.994 times 6. I'm sorry. Yeah, 9994 times 6. Sounds like Waverly's back there working a little ahead on us here on the lab. And so when I add all this together, I get 254.5224. And we've got a couple of empty slots over here. So we need to round those off. Remember, there's a different set of rules for addition now. This is our addition rules. It's different from the rules for significant digits for multiplication and division. Okay? So this is going to round off then. 254.52 grams of strontium chlorate equals 1 mole of strontium chlorate. Okay, and we have a an equality statement from which we can build a conversion unit up here. We want to match what's remaining up here in this previous step with the side of the equality statement. Match the units and species and put that part of the equality statement on the bottom of the conversion unit. So 1 mole needs to go on the bottom here. And then the mass, 254.52 grams strontium chlorate, goes on the top. And we are ready now to do some math. Let's do the cancellation. There you go. Good. For those of you listening to the video and trying to figure out what in the world is all that whining sound, well, that's them whistling a little tune we do to remember to cancel as we go.
I'm sitting at the front now.
Hi, Mom. Okay.
Hey, Mom.
So we're going to multiply everything across the top. Then hit equals and divide separately each of the things on the bottom. We've only got one on the bottom here that really matters because dividing by 1 gives us the same number. We're going to divide by 120.368. And I got 8.45.806.1943. Okay. The units we have left are grams. The species is strontium chlorate. We need to include those. Grams of strontium chlorate. And then we need to round off to match the number of significant digits that we need. Well, there are 3 here. Remember, we're only going to use measured or calculated numbers. Measured, calculated, calculated. So these other numbers don't really matter. Those are all counting numbers. So this one has the least digits, 3 digits. Going to underline, do our arrow to show we're rounding off. You can't put an equal sign because these 2 numbers are not going to be equal. We get 8.46 grams of strontium chlorate. All right, now we have to compare this number to the problem. And we had 5 grams of strontium chlorate in the problem. Okay? So this has to be the limiting reactant. If the amount we calculate is greater than the amount given of that species, then that's the limiting reactant. So strontium chlorate is the limiting reactant. Okay?
So how do we, to do the spherical yield thingy, we take our limiting reactant.
We take the given amount of this limiting reactant and do the same thing to the product we're looking for.
Okay.
And to find our excess reactant that's used, we start with the given amount of limiting reactant and calculate to the magnesium sulfate. Okay? Now you're lucky because you started with strontium chlorate a while ago. You don't have to do that third calculation. Everybody thank Jay Breezy.
Thanks, John.